Okay. Hello. I know I am late this week. I got to get 11.6 out to you. So that's what we're going to do right now. This is 11.6. Last section in chapter 11. Okay. Let me remind you, if you had, remember we had exponentials. Remember it was if a to the x equals a to the y, meaning these bases are the same, then you can set exponents equal and solve. Okay? These bases are not the same, so I cannot. Now, this is a 3. Is there a base 3 in 12? You can't turn 12 into anything that's base 3 to the something. Okay? It doesn't work. So this can't be solved exponentially. So this is, before we had stuff that was in logarithmic form, and I said if you don't know how to solve it, you switch it out. When in doubt, switch it out, and you turn it to exponential. Well now, if you're an exponential and you can't solve it, you change it to logarithmic form. Okay? So this would be log base 3 of 12 equals x. Now you can do this because I've already taught you change a base formula, correct? Yes, we did that at 11.5. This becomes log 12 over log 3, which again, remember that's base 10, and you can do it on your calculator. All you do is that, okay? So when you do that, I don't know, it comes out to be some decimal number, okay? But you get x equals, and you have a number, okay? Now, I needed to remind you of that because we're going to be doing all kinds of solving with logarithms in this 11.6. So for instance, log base 2 of x plus 5 cubed equals 4. Now, in logarithmic form, the only thing I could do would be change a base formula, but the x is here. So I can't, there's nothing I can do. I can't put on the calculator log of x plus 5 cubed divided by log of 2 and get an answer. So that's not going to work. So we can't do it in logarithmic form. We change it out. So you get base 2 to the 4th equals x plus 5 cubed. Exponential form. Well, okay, we can do this. 2 to the 4th is 16. And x plus 5 cubed. All right. Well, how do we solve for x? We have to get rid of this. If it's being cubed, you take the cubed root. And whatever you do to one side, you do to the other. So you get the cubed root of 16, and here you get x plus 5, because that cancels that out. All right. Subtract 5. I have negative 5 plus the cubed root of 16 equals x. I solve for x. Now, this is a really good answer. The only problem is that can be reduced. The cubed root of 16 is the same as the cubed root of 2 times 2 times 2 times 2, which means I could rewrite it as 2 cubed times 2. There's a set of 3 of them. So that means this comes out, and you have 1 left over. Okay? Think of it, remember, 2 to the 4th. If we had the cubed root of 2 to the 4th, 3 goes into 4 once with 1 left over. Remember that? Okay. So it's negative 5 plus 2 times the cubed root of 2. That's what x equals. So you just had to simplify this. Okay? All right. Let's look at another scenario. What if I had... Oh, okay. Before I show you this next scenario, there's one more property you need to know. Okay? If you have log a of x equal to log a of y, meaning, look at the logs. Same base, okay? If the bases are the same and it's just a single log equal to a single log, you can get rid of it and just say x equals y and solve. All right, knowing that, if I had log base 2 of x plus 1 minus log base 2 of x equals log base 2 of 7, they all have the same base, okay, but I don't have a single log. I have 2 logs equal to a single log. But do I know how to take 2 logs that are being subtracted and smush them together into a single log? Yes, you do. If it's subtraction, it becomes division. This divided by that equals log base 2 of 7. Now, do I have a single log equal to a single log? Yes, I do. So I can get rid of the logs and deal with just x plus 1 over x equals 7 over 1. Why did I put it over 1? Because when you have a fraction equal to a fraction, you use that means extremes rule. This times this equals that times that. So 7 times x equals 1 times x plus 1, which is just x plus 1. Move the x over, you get 6x equals 1. Divide by 6, and x is 1/6. And you've solved. All right, think about that. Let's look at another scenario. What if I had log of x plus log of x minus 21 equals 2? First of all, if nothing is written down here, what is the base? 10. It's always 10. Did somebody knock on my door? It's okay. Ask Rhonda. You know what I mean? I know that he was going to create it. Therefore, if he created it, he would be teaching it. But because he's not creating it, we decided to not create any more CJ until Mark got here. So and I told him it's taken off. So because he's not creating it, it wouldn't be there online to teach it. So the answer would be no at this point. Look and see if he's maybe in E2. Okay. But that would be why it's not there anymore, because if he's not creating it, he's not teaching it. Okay, so this is base 10, but I have logs on this side, but I don't have a log over here. And as it stands, I can't switch it out to an exponential because I have 2 logs. But can I condense them? Yes, I can. I can change this to log x times x minus 21 equals 2. Now remember, what did I say this base was? 10. I can't do change of base formula. There's nothing I can do. There's nothing else I can do in logarithmic form. So I'm going to change it to exponential form. So I get 10 squared equals x times x minus 21. All right, we're going to solve for x. 100 equals x squared minus 21x. I have an x squared. What do you do when you have an x squared? You get everything on one side, 0 on the other. See if it factors. If it doesn't factor, then complete the square or use the quadratic formula. So I'm going to move this 100 over. So I get 0 equals x squared minus 21x minus 100. Let's see. Are there multiples of 100 that subtract to give me 21? 25 times 4. It does factor. X and 25, x and 4. Now, to get a negative 21, I would need minus 21 plus 4. Now remember, you just set each multiple equal to 0 and solve. So here you get positive 25, and here you get negative 4. So I'd have to move these over. Now, I have two answers. Which one do I use? Do I use both? Well, I need you to look back here. Anything here cannot be negative, and anything here cannot be negative, okay? Because this can't be negative, it doesn't matter what you would do to this, it's always going to be positive. It's always going to be 10 squared, 10 cubed, whatever. That's why this can't be negative, okay? So if I plug in a 25, 25 minus 21 is 4. 4 times, I get a positive number. If I plug in a negative 4, negative 4 times negative 21 is negative 25 times negative 4. Oh, I get a positive. So actually, let me check just to make sure of something here. Oh, okay, that's right. I'm not going to the original problem. I got to go to the original problem. If I put x is negative 4, can't work. X is negative 4, you get negative 25, can't work. It's got to be the positive one. So the only answer that works is a 25. Okay. So let's look at an application to this. Because the other thing they're going to have you do is do some word problems. And it has to do with interest. Okay? It has to do with accounts and interest. Now, we have two formulas. We have compound interest with a what we call finite period. So it compounds quarterly, it compounds annually, it compounds semi-annually, it compounds monthly. Okay, if it compounded monthly, it would compound 12 times. If it compounded quarterly, it would compound 4 times. If it compounded semi-annually, it would compound 2 times. Annually, 1 time. Okay. The other way is what we call compound interest, and it's continuously. So it's constantly compounding, continuously compounding. That's not a finite period. If it has a finite period, then your formula is A equals P times 1 plus R over N to the N times T. And if it's continuously, it's A equals P times E to the RT. Now, with that said, A means the account balance. P is the principal deposited, how much you put in. R is the rate that you're earning, but it has to be not in percentage. It has to be in decimal form. N is the number of times compounded. And T is the time left in account in years. Okay, with all that said, let's look at a problem that says, how much money will there be in an account at the end of 5 years? At the end of 5 years, if $1,000 is deposited, at 6% compounded quarterly. Compounded quarterly. Now, let me remind you, it's A equals P times 1 plus R over N all to the N times T. So how much will be in the account? So that's what we're solving for. A equals. Now, what was P? P was the principal, the amount you deposit, the amount you start with. That's 1,000 times 1 plus the rate. The rate cannot be in percentage. It has to be in decimal. So 0.06. Now, the N is the number of times it's compounded. If it's compounded quarterly, it's compounded 4 times. And then 4 again times the time in years, which is 5. Now, the worst part about this is you have to remember your PEMDAS. What do you do first? You do what's in parentheses. So A equals 1,000 times this. 1 plus 0.06 divided by 4. Well, 0.06 divided by 4 plus 1 is 1.015. And then we can do the 4 times 5 on the outside here. It's 20. Okay, that's parentheses. What comes next? Exponents. So you need to do this to the 20th power, and then the answer that you get on your calculator, then you multiply it by 1,000, and it comes out, you should come out with 134686. And they wanted to know how much money will be there. So after 5 years, you start out with 1,000, and you will have made $346.86 at 6% compounded quarterly. Not very much, huh? Kind of sad. All right. That's with one type of formula. Now let's look at another one with the other type. Let's do the same thing. We're going to deposit $1,000 at 6% for 5 years. And there is no how many times is it compounded because it's compounded continuously. And that was A equals P times E to the RT. Now, what is E? Remember on your button, LN, there was an E? That's what E is. So you have to go to this function on your calculator, okay? A is going to equal principal times E to the R, what's the rate? 0.06 times 5. So that is A equals 1,000 times E to the .30. Okay, I'm going to make sure I have the answers there. 0.30. So you find out what E to the 0.30 is, and then you multiply it by 1,000, and you should come out with $1,349.86, which is just a few more dollars more. It is compounded continuously rather than quarterly. Okay, so you're going to have to use. That's weird. You're going to have to use these two formulas, that one and then this one. Plus, I've already, which means write them down, because if I can't remember them, you shouldn't have to. Write them down. And T. Okay, this is when you have a number of times it's being compounded. This is when it's continuously. Okay, and that's going to be some of the applications. That is the application that they're going to have you do. All right, that's 11.6. You have an exam this week, I believe. So you got a lot to do. Let me know if I can help you at all. And have a good week. All right, bye.